Hi everyone. Hi everyone. So today we're going to work on an actual test. Finally, we're finally done going through every single part and we're going to actually conduct a hypothesis test. So we do have a couple of things we have to talk about first before we actually do a problem. So here we're going to find and interpret our p-values, and then we're actually going to use the p-value in a z-test. So remember, when we first talked about p-value, we defined it as the probability. Okay, basically it's the probability of your test statistic in the normal curve. All right, so we're going to use that. Now remember, our rule is that if the p-value is less than or equal to alpha, which is given to us in a problem at this point, you're going to reject H sub O and accept H sub A. If your p-value is larger than alpha, you're going to fail to reject H sub O. We're not going to accept H sub A either. Kind of like we need more testing before we can do anything. Okay, so now we're just going to practice accepting or rejecting our H sub O based on the p-value. So here's the p-value, 0.0237. If our level of significance is 0.05, are we rejecting or failed to reject? So we're going to take our p-value, we're going to compare it to alpha, and we're going to see what happens. So our p-value is 0.0237. Compare that to our alpha, which is 0.05. All right, so 0.05 is larger, 0.0237 is smaller. And since our p is smaller than our alpha, we're going to reject H sub O and accept H sub A. Okay, and that's how we're going to make our decision. Okay, all right, let's try the next one. So if our p-value is now 0.01, so we're going to do 0.01, and we're going to fill in this blank. Oh, wait, I have that in the wrong order. 0.0237 compared to 0.01. Okay, notice that 0.0237 is bigger now than 0.01. So here we're going to fail to reject. Okay, all right, and we're not accepting H sub A here either. We're like, need more testing, status quo, things like that. All right, so that's how we're going to do it. Okay, we're going to take our p-value, we're going to compare it to our alpha, and make our decision. And again, where are we getting our p-value? Our z-chart. Okay, so how are we going to find it? All right, so for a left tail test, we're going to go area in the left tail. So we're going to read our chart. Right area in the right tail. Remember, we're going to go back to our rules here. It's going to be 1 minus our chart. And if it's area in our for a two-tail test, we're going to do 2 times whichever one it happens to be. If we have a positive z, we're going to do it to the right. If we have a negative z, we're going to go to the left. And we're going to multiply that by 2. We're going to do examples of all of these. Okay, so let's find the p-value for a left-tailed hypothesis test with a test statistic of z equals negative 2.23, and then decide whether we're going to reject H sub O when the level of significance is 0.01. All right, so the first thing I noticed is that it says a left-tail test. So I'm going to draw myself a picture that has to do with a left-tail test. So I have negative 2.23. Our p-value is going to be this area right in here. It's going to be the probability that we're going to be less than negative 2.23. So I'm going to go get my z-chart. Here it is. And I'm going to look for negative 2.23. Negative 2.2 and 3. 0.0129. Okay, so this is 0.0129. Okay, so that's your p-value. Okay. All right, so we're going to take that and compare it to our level of significance, which is 0.01. Okay, so p compared to alpha. Our p is 0.0129. We're going to fill in our blank because our alpha is 0.01. Okay, so this is bigger than 0.01. Okay, our p is larger, so that means we're going to fail to reject. Okay? All right, let's try this one. So we're going to find a p-value for a two-tailed test. I'm going to highlight that. We're going to do a two-tailed test. Okay, here's our test statistic. And decide whether to reject H sub O with a level of significance of alpha 0.05. Okay, so the first thing I'm going to do is draw my picture for a two-tailed test. Again, can't tell you how much important it is to be able to draw your picture. So 2.14 is a positive value. But we're going to actually color both sides of the world here, okay, because it's a two-tailed test. And we have to look up 2.14 in our z-chart. .14, which is 0.89838. But we have a problem. Because it's a right tail, we're on the right side, we're on the greater than, we have to do 1 minus. So that's 0.0162. Okay, everybody remember our rules because we want this. So it's kind of like, okay, I've determined what kind of test. Now I got to go back to what we did at the beginning of the quarter where I'm going to do, okay, I'm looking in the chart, I'm going greater than, I got to do 1 minus. If I'm less than, I got to do, read the chart. Okay. Now, before I decide if I'm going to do p-value compared to my alpha, because this is a two-tailed test, I need to multiply this by 2. And that's what I'm going to compare to my alpha. Okay, so let's see, 0.0324 compared to my alpha. And I do believe alpha is larger, so this is going to be less than. So our p-value is smaller than our alpha, which means that we are going to reject H sub O and accept H sub A. Okay. All right, so hopefully that cleared up a little bit of questions that you may have had. All right, so now we're going to do a z-test for the mean. Okay, so we have our understanding now of our comparing to our alpha and our p-value, where the p-value is coming from because we got to get our test statistic. Well, what's our test statistic? Well, it's going to be the z-test. So z-test for the mean, okay, we're going to use the z equals x bar minus mu omega over the square root of n. Okay? Now, there are the conditions that have to be met. Somewhere in the problem, it has to say that the sample that we're taking is random and that one of the two have to be true, that your population is greater than or equal to 30 or it's normally distributed. Okay, it's got to be one of those two. All right. Okay. So, here's our, remember how we went over the list of what's in our hypothesis test? All right, so I've added to it so that we can continue building on it. All right, so the first part is making sure that we can do the problem. This is known. Our sample is random. Population is normally distributed or greater than 30. So this is, can we do it? Okay, that's our check. All right, so now you're going to state your HO, your HA, and which one of these guys is the claim. Remember, HO is your null hypothesis, HA is your alternative hypothesis, and one of those is the claim. And remember, HO always gets the equal to's. The null hypothesis is equal and true. We're going to assume that's true before we start. You're going to identify what your alpha is. You're going to determine the type of test. Left tail. Is it right tail? or is it two-tail? Okay, now remember, type of test is all based on H sub A. Okay, again, key to life, getting those hypotheses, HOHA down. Okay, so you're going to find your test statistic. Okay, so you're going to do that computation. Find your area corresponds to the z. That means you're going to find your p-value. You're going to look it up in the chart. Okay, oh, back when you determine the type of test, you're also going to want to draw the picture. Should we say diagram? That sounds a little bit more adult. Okay, you're going to make your decision. Okay, so you're going to compare your p-value to your alpha and make your decision. And then you're going to write the conclusion, which is what we practiced the other day. You know, is there enough evidence to support the claim, reject the claim, that kind of stuff. All right, so we're actually going to do a problem. And it looks like this. I know there's a lot of words. Don't panic. In auto racing, a pit stop is where the racing vehicle stops for new tires, fuels, repairs, and other mechanical adjustments. The efficiency of the pit crew that makes these adjustments can affect the outcome of the race. A pit crew claims, okay, so I'm going to start highlighting, claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds. A random sample of 32 stop times has a mean of 12.9. We're going to assume the population standard deviation is 0.19 seconds. Is there enough evidence to support the claim at alpha at 0.01? All right, so there's a lot here, so let's just take it apart. All right, so the first thing we notice is we got to write our HOHA. So that's the first sentence. The claim that its mean pit stop time is less than 13 seconds. Okay, so mean 13 seconds, less than 13 seconds. Let's put seconds here. That means H sub O is greater than or equal to 13 seconds. Okay. All right, and this guy here is our claim. Okay, any questions? Yeah, think about that. All right, so our next thing on our agenda is what is alpha? Okay, so we want to make sure that that's what we're testing against. All right, is it a left, right, or two-tail test? So this is a left tail test. Okay, so I'm going to draw my picture. Okay, which means the z that I'm going to get is going to go down here. So I have to find my test statistic. Okay, so let's find our test statistic. Okay, so we're going to do z equals, our sample mean was 12.9 minus our population mean, which is 13. Our population standard deviation is 0.19. And our sample was 32. Okay, now I have to stop here because did not make sure that the sample size is larger than 30 and that we have a random sample. So it does say random sample and our sample is 32. So I should check that in the beginning because if they weren't, we wouldn't be able to do the problem. All right, so let's do the computation. All right, I did it earlier and I got negative 2.98. Okay, so that goes here. And that is what I'm looking up in my Z chart. Okay, so negative 2.98, negative 2.9, and 8.0014. Okay, that's your p-value. Okay, All right, so we're ready for our test. Let's make sure we have everything. Test statistic p-value, draw our picture, left tail test. Okay, so let's do our decision. Okay, so we're going to take our p-value, which we said was 0.0014. Okay, there's our p, and we're comparing it to our alpha. Alpha, 0.001. All right, that is less than. Less than. So that means we're going to reject H sub O and accept H sub A. Okay. All right. Now, so far as everybody see how it's all fitting together and why we did all those individual parts last week. Okay. So now we're going to write our conclusion in terms of the problem. Okay, so this goes back to what we did the other day when we had, are we going to use the words, there's enough evidence to reject, enough evidence not to reject, that kind of stuff. So since H sub A is the claim, and we are rejecting H sub O and accepting H sub A, we're going to say with, now we're going to add things here, a level of significance, because we're going to include what we tested against, of 0.01 and a p-value of 0.0014. There is enough evidence to support the claim that the mean pit stop time is less than 13 seconds. Okay, now we're going to talk about the type of error. Type 1 error can occur okay, so I'm putting together what we did the other day with the errors. Now here's how I worded it. That the actual population mean pit stop time is not less than 13 seconds. When we rejected H sub O. I'm sure there's a better way to say it, but that's what I wrote. Okay, I know that's lengthy. Okay, we're going to practice it. So I'm running out of time here on my video. There's another one here if you want to try it. We're going to keep practicing this. Let me know if you have any questions, guys. Please stay safe out there. Take care of yourselves, and I'll talk to you again real soon.